Welcome to AI Podcast. I'm David, and with me is Maya. Today we're turning a recent research article into a clear, easy listen. The paper is called Gorilla Large Language Model Connected with Massive APIs. Here's the conclusion up front. Gorilla fine-tunes an open model so it can write correct API calls, and it trains the model to use retrieved documentation, even when that documentation is messy or imperfect. In tests on a large benchmark of machine learning APIs, it's competitive with strong commercial models and tends to hallucinate fewer functions and arguments.
Thanks, David. So, big picture, this is about helping AI systems call the right tools without making things up. Got it.
Exactly. A quick note on who wrote it. The work is led by Shishir Patil and Tianjun Zhang at UC Berkeley, with collaborators. Berkeley has been very active in this space.
All right, set the stage for us. What problem were they staring at?
Today's language models can talk about using tools, but reliably choosing the right API and filling in the right parameters is still brittle. Think of the chaos. There are thousands of functions across different libraries, the docs change frequently, and retrieval systems that bring the docs to the model can return partial, outdated, or irrelevant snippets. That's where hallucinations creep in. The model might invent an argument name that doesn't exist, or even call a function that isn't real.
I've seen that. You ask for a function and the model confidently fabricates one. So the gap here is dependable tool use at scale, even as documentation drifts.
Right. Previous approaches taught models to use a small, fixed set of tools, or they relied on prompt engineering without training the model to handle imperfect retrieval. And evaluation was murky. If a model produced code, was it wrong because it picked the wrong tool? Or was the tool correct but the arguments wrong? Many benchmarks didn't separate those failure modes, so it was hard to tell where progress was happening.
So they needed a cleaner recipe for training and a cleaner way to measure success. What's the core idea?
2 pieces. First, a training method called retriever-aware training. During fine-tuning, the model sees a user request plus snippets of documentation fetched by a retriever. Those snippets can be good, bad, or somewhere in between. The target output is still the correct API call. Over time, the model learns to use helpful docs and ignore distracting ones. That makes it more robust when documentation changes or when the retriever isn't perfect.
So it's training the model on the messy reality it will face later, not a sanitized classroom.
Exactly. Second, they propose a practical way to score outputs. Instead of just comparing strings, they parse the generated call into an abstract syntax tree, or AST, and check whether the function exists in the benchmark's registry, whether the required arguments are present, and whether extra, invented pieces slipped in. They report 3 outcomes: correct calls, hallucinations where the model invents an API, and errors where the API exists but the arguments are wrong.
That's helpful. It separates you chose the wrong tool from you chose the right tool but used it incorrectly. How did they test this?
They build a large benchmark from 3 places developers actually use: Torch Hub, TensorFlow Hub, and Hugging Face. The training data is instruction style, so the model learns to respond to requests like loading a sentiment model with a certain accuracy or fetching a ResNet variant. They compare Gorilla against strong baselines, including well-known commercial models, under several retrieval setups. One is an upper bound, where the retriever returns the perfect doc, and others use more realistic retrievers that sometimes miss.
And what happened?
In the controlled setting with perfect retrieval, Gorilla's accuracy is very high on 2 of the hubs and substantially better than general-purpose models on picking and parameterizing the right calls. Just as important, hallucinations essentially disappear in that upper bound condition. When they replace the perfect retriever with more ordinary ones, accuracy drops, and you see why retrieval quality matters. Still, the training recipe helps Gorilla stay competitive and often reduces those made-up functions and arguments.
So the model is strong when you feed it good context, and it degrades gracefully when the context is noisy. Did they look at real-world issues like documentation drift?
They did. A nice aspect of retriever-aware training is that the model is practiced at ignoring misleading snippets, so when a function name changes or a registry reorganizes, Gorilla is more likely to adapt than a model trained without that signal. They also audited the evaluation metric by comparing it to human judgments and found it aligned reasonably well, and a majority of generated calls ran end-to-end once the environment was set up.
I like that they actually tried to execute things. Code that only looks right can still fail in practice. Now give me the skeptical read. What should listeners keep in mind?
First, scope. The benchmark focuses on machine learning-centric APIs. That's a great place to start, but we shouldn't assume identical performance on cloud SDKs or SaaS endpoints with authentication and side effects. Second, retrieval realism. The upper bound results are useful for understanding the model's ceiling, but real deployments will live in the messier middle. You'll want to invest in indexing and ranking so the model usually sees the right slice of docs. Third, the AST metric is a proxy. It's much better than string matching, yet it can't fully capture dependency issues, environment setup, or downstream task success. And finally, like many LLM papers, large-scale uncertainty estimates across different random seeds and prompt variants are limited, mainly because those runs are expensive.
All fair. It sounds promising, but not magic. What about reproducibility? Can a team kick the tires?
Yes. The authors release code, data, and model artifacts, with documented splits and hyperparameters. That makes it feasible for teams to replicate the core findings and try Gorilla on their own tool catalogs.
Good. Let's circle back and unpack a couple of terms for listeners who don't live in this stuff every day. When you say retriever, you mean the piece that looks up relevant documentation for the model, right?
Exactly. Imagine a search step that grabs a few chunks of an API reference. The model then reads those chunks as context and decides how to form the call.
And hallucination here isn't a fantasy story. It's the model inventing a function or an argument name that doesn't exist.
Right. The goal is to drive that down, because invented arguments are costly for developers and risky if the API controls something important.
Before we wrap, can you connect this to everyday development? Say I'm building a service that strings together models from different libraries.
With a Gorilla-style system, your assistant could choose among many available functions and fill in the parameters more reliably, even when the docs are a bit out of date. It's particularly helpful when users add constraints like meeting a certain accuracy threshold or preferring lightweight variants. The system doesn't just pick any working call, it aims to satisfy those conditions.
That makes the assistant feel more like a careful engineer than a guess-and-check intern. Where does this go next?
3 directions. 1. Broaden the benchmark beyond machine learning hubs to include cloud services, SaaS APIs, and SDKs with authentication, streaming, and side effects. 2. Keep pushing retrieval quality. Better indexing, hybrid, dense, and sparse search, and version tracking so the model sees the most relevant, up-to-date slice of docs. 3. Combine the AST scoring with larger-scale execution tests in sandboxed environments so we measure not just whether the call looks correct, but whether the whole task succeeds. I'd also add more systematic uncertainty reporting across seeds and prompts so teams know how stable the gains are.
Practical and measured. So, to summarize, Gorilla teaches an open model to write API calls in the wild, not just in a tidy lab. It reduces made-up calls, handles documentation shifts better than many baselines, and gives us clearer ways to evaluate progress. It's not a solved problem, but it's a meaningful step.
Well said. If you work on tool-using AI systems, the takeaway is simple. Train with the kind of imperfect context your model will actually face, and judge outputs with metrics that separate wrong tools from wrong arguments. Gorilla packages both ideas in a way others can build on.
That's it for today's AI podcast. If you want us to adapt more research articles into listener-friendly episodes, send them our way. Thanks for listening.
Thanks, everyone. See you next time.